So I'm recording.
Awesome. Sisai, you want to introduce yourself and let's get started.
Okay. My name is Sisai. Before I begin my presentation, I would like to thank especially two people. The first person I want to thank is my wife. She enabled me to be here. Over the weekends, she had to keep my kids, our kids, and I was comfortably here to attend the 6 weeks classes. In addition, I spent numerous times on my project and my homework that I took from this class. Without her, this would have not been possible. Second is Mr. Shavan. He's not only a teacher. He gave his life for this class and for everyone that comes in here. And thank you, Mr. Shavan. And this is the smallest word I can say about him. I work for T-Mobile. I have a full-time job. Besides this full-time job, I also teach for 3 universities. So pretty much full-time job and another full-time job. And these, the only way I was able to do this is if I was to take some time off from work and go through it. I came to this class with no coding knowledge, no programming language knowledge at all. So I learned a lot from Mr. Shavan, especially in the first week. Now, I want to focus on my project. This is a classification and clustering anonymized mobile call details and text records to find usage group using logistic regression and time series. So I'm applying 2 models, the logistic regression model and the time series. We have talked about the logistic regression model a lot, and that will come towards the end of my presentation. However, I will focus on the time series because we have not talked about that earlier.
So can you increase the
Okay.
top right?
Top right here,
There's and plus.
plus here. Is that enough?
Is that good?
Well, one more, please.
One more?
Yeah.
Okay.
Yeah.
Now, there was a study that was conducted by AT&T regarding the use of cell phone to cluster and classify users and based on their behavior. Just to give you a little bit of background on the cell phone, since I'm in the industry, there was a recent study that stated that about 68% of adults use at least a smartphone, and this is up by 35% since 2011. In here, about 85% of people above and older on at least a smartphone. And as a result, this is an important tool to classify and study human mobility. This is the focus of my project tonight. So knowing where and when large number of people spend their time can tell you where they're spending their time, where they're spending their, what they are doing in a particular time, and be able, so in other words, we can be able to target them if we want to sell particular goods or services to them. Now, the problem that I want to solve in this project is that I want to apply the time series to determine usage of text and call detail patterns over time, and group all call details and text records by time, and which could be an indicator of who is calling or who's texting at a particular day and time or hour. And I segmented a particular month, day, and the entire data frame as well, which I'm going to show you shortly. So, and also I looked into the common locations of calls and texts that were made on a particular date, that is December 23rd, 2010. So, and I also applied, as I mentioned, the classification technique, supervised technique, which is using the logistic regression model, and applied the accuracy model. Now, my data comes from 3 different sources. The data is for the time frame from September through December 2010, and the first data, now everybody talked about this, so I'm not going to repeat and emphasize it. I imported all the libraries, the tools that I need to analyze this data. My first data comes from AT&T, the cell towers in Dallas. This is what you see on the first table here. So I called it into my notebook, and this is the type of data that I have, and we have objects and plots and so on, and I called the head, and we have 83 rows and 10 columns in that data frame. And the second data set I have is for call details, and I obtained this from a website. This is it. The call types, or the call type, the details of the data type, and I renamed some columns. I changed the columns so that it best fits to my purpose, my project, and dropped some columns which I didn't need. And this is the shape of the data. I have 52,038 rows and 4 columns. This is all what I needed. And the third data set I had was for text message records. If you work in the telecommunication industry, you would see that some companies do retain text messages using a different server, and they use different servers for call details. So I had to bring these together. So this is the data set again for text messages, and renamed some columns, and dropped a few columns, the 3 columns you see, and also mapped some of the features in the columns, like the incoming text to 0, the outgoing text to 1. And now I have the data set, which has 54,446 rows and 2 columns at this point. Now I had to merge all these 3 data sets together. Merge them. This would be the data frame that I'm looking at in this project. The size is what you see, and the type. And you can see a lot of non-values. There are no non-values in there. So I had to do some type of handling the missing values. I chose to do the fill NA method with using the forward fill, and replaced all the non-values. This is all what it is. And the shape again is 54,446 and 16 columns. Now at this point you see, since I did data annotation, there are no non-values, right? Now, so the data frame generally looks like this. So I called in the 3 top heads of the data, And I was able to export these data frame to using to a CSV and then export it to my desktop. Now, time series is the new thing. We have not looked at this before. I had to index the data frame using the date and time. That's why you see the very first column there. It is in terms of the year, month, and the date, and also the time in which the phone calls and text messages were stamped and obtained by the server. So now I selected for my time series studies, I selected 15 days of records, quality records, starting from October 15th through October 31st. So that is my aid for this time frame, October 15th through October 31st, 2010. And I indexed it into hours. You see the very last column will show an additional column here that is indexed by hour of each call that was made. And I had looked at what would be the mean call details and text records per hour in the month of September 2010. So I had to do a main calculation, summarize it, and then looked at the patterns of voice calls and SMS volumes on a different days of the week and hour in 2010 for September 2010. You see that's the call direction. You see this is per hour. First hour it's very low, and the first half hour was very low, and in the first hour you see there is at least duration of calls that are low, and the durations are high, meaning that the number of hours that people spend on the phone is high, but the incoming and outgoing calls were very low compared to the other hours that you see. So this is per mean hours. So and
does that mean like at 3 o'clock there is this much text length, and that is how you read the stuff?
yes, that
Okay.
is this graph is based on the average values that you've seen of the incoming and yes of month of September.
3 o'clock. This is what it is.
Yes. So now, and I also asked myself, what is the mean call detail and text records per day and hour in the month of September 2010? I think that is the earlier one was a week in hours, right? And the second one was a day and hour. So this is the table, and I had to this is how much it was. That was the difference. You see, during the first hours, there are no calls, almost barely no calls, but around 10 and the 15 hours, there's a lot of phone calls, and it increases, and again it goes down. And I looked at this graph carefully and tried to determine who is actually calling at these hours in different times. Are they students? Are they employees? Are they, what type of people are they are communicating during this time? That's my intent in this study. So if we were to generalize from this graph, we can say that very few people call in the first hour, first section of the 24 hours, right? And but they are busy during on the 10th and the 15th hour. Maybe this is the time when people get a break during maybe at their work or even during their school time. And they
Can I ask a quick question? Yeah?
Sure.
It says average number of calls, right? So like, is that the number of calls normalized or something, because the range is like from 0 to 1?
It is average phone calls that
Like you will make one call at least, then like average would be 1. So I was just trying to understand like why is it 0 to 1 as a range? Average.
because I think I calculated the mean.
Me?
The mean.
So, okay.
And renamed it. We renamed the axis.
Or rename the axis?
Renamed the axis.
Okay.
Yeah. Just to give it like a label so that I at least know that is to indicate the average number of phone calls per time. This is the time series for the entire month, the entire time from September through December 2010, and I am going to show you what the graph look like. This is very busy graph, right? The number of calls per hour. This is typical of without segmenting it, and this is also the number of incoming and outgoing text messages per hour from October 15th through December 31st, 2010. And I did for the comparison purpose, I did another time series study on the month of November 2010. That's supposed to be 2010. And the graph you see here is completely different from what we've seen earlier, right? See in the first hour, at least the first quarter of the hour, people were not texting, not calling, and the duration was less, the direction was less as well. And then it was pretty much steady, meaning that maybe these are people who are not at work and texting and calling each other. And I was interested to just to look at what is happening on December the 23rd. And my finding is that that there are a number of incoming and outgoing calls during, I would say, the 6 hours, the 7th, around 7 a.m. in the morning. Maybe to say hello to each other and to wish each other happy holidays, right? And then eventually it goes down and steady as the day progressed the end. And this is the distribution, calls duration per hour. Not many people stay on the phone for a very long time. You can see that many of them were calling at least an average of between 500, the first 1 minute, 2 minutes phone calls. Now this is just a comparison, scatter plot matrix for call direction and text direction and text duration, just to compare and contrast. This just to see is call direction and call duration to see how much the distribution was. The text direction first, call duration, that was the distribution. So this is how you use this graph to compare and contrast the features there. Now I was interested also in looking at the tower locations on that phone calls were made and received on December 23rd, 2010. So using CartoDB, um, this is how I graphed it. This is how I was able to point at where the phone calls were pinged or transmitted through certain towers. These are the tower locations. As I see, as many people were concentrated in I think that is East Dallas, right? And a few people in main downtown Dallas, and so on. I almost did what Mr. Gorino did earlier. I was able to do
The torque.
the torque. It worked, but it wasn't bright enough, so I had to stick with this one. Now, logistic regression, and this is a classification model, and model evaluation is what I did. I have the data frame, and I dropped some features there. I needed only to have the call direction, call duration, status, and I didn't use the timestamp, but I used I think the text direction and text length. Non-values, they were about 2,410. I needed to do some type of data amputation. I used some averaged and forward fill again, and came up with 0 missing values. The shape is again 54,446, and other things that I was interested in to see the direction of phone calls, whether it is incoming or outgoing phone calls. So I splitted that, used from the calls direction column, split it into 2, and created the dummy variables, 0 and 1. And I'm going to use these as well in the features in my logistic regression. Now I had to merge these new column with my data frame, my original data frame that I showed you earlier. And you see these dummy variables there are existing in here. I joined them. These are towards the end. And so for my logistic regression, I defined call direction, text direction, text length, and call direction and duration as my features, and status as the response categories. Because in logistic regression, we need to have 2 categories that we can classify them into 2 categories, right? And split the data into 2 training and testing sets. And I fit my data into the logistic regression model. Pretty much this is what everyone talked about, right? And make the prediction on testing set and calculate the accuracy. The accuracy was about 0.821, and I asked myself, what is the null accuracy here? The null accuracy is the most frequent class in my data set, which I used to base it against what I wanted to measure in my classifier. And my test result is 0.82, and the null accuracy was 0.17815, and I created the confusion matrix. Pretty much, I think we've talked about this, right? And this was what it is, and determined my ROC curve and also determined the AUC. My model is not that great. I think I need to do more feature engineering in here to see a better result, a better outcome of it. the more this curve is towards the S, the S curve, right? They go up, more go up towards like that. It's better. So that's what I'm going to play with in during my weekend if my wife allows me to do that. So and pretty much the histogram of predicted probabilities by actual response values is what I showed you. So generally that's what I did.
So great use of time series.
Yes, great use of science.
Wonderful. So what's next for you? I know she's got to allow you to do some work, but
No, he didn't say.
This week is a great week for me, I think, and also for my family. The reason is because when I came to the academy and talked to Mr. Shivan, I took that to my office and I said, this is what I'm interested in to learn. And that went to my director and my VP, who was sitting in Seattle. And they came back with a response. I actually wanted them to pay for this course. And they said, no, well, we don't know what you're going to use it for and how we are using it. We don't know. So I want you to write down your job description for these. So I wrote my job description and sent it to them. So this week they are in a meeting to discuss about this. And hopefully they will come back with a good response. And I think I will be doing such time for my department, for my country.
for that and more, we got to give it.
But I have a long way to go. And
Are you still planning on hiring Mario?
Yeah.
Is it time to stop him to move to?
Mario is. I was asking him not to go to Chicago, but he has to go. So thank you for your support here, and I really appreciate your.
No, wonderful, wonderful. You guys hold on. I have your certificates. All right, so you can shut down your laptop. Give me your certificates. It's been a long night, but it was a.
You
guys can collect.
Yes.
Yeah, so as part of Divergence Academy, they get Texas Workforce Commission approved certificates, and it is also a digital certificate. Now, even though you're getting a paper certificate here, you're going to get an email with a digital link, and you can import that to your LinkedIn profile and demonstrate your capability to all the future employers. Of course, you have a data scientist job, that's great. Well, you don't need to find another employer. It's good for T-Mobile, but you know what? For us, this is a demonstration of our success of teaching you and others. So put that on your LinkedIn profile, all right? Thank you. And the first one I have is, well, you guys can come one at a time. We'll take a picture together, all right? Dr. Brehon McConan. All right. So here you go. Hold this. This is yours. Okay. Very
Because
good.
I have to put you much about that.
Yes, wonderful. Thank you. Stay back. I have Martin. Martin, go on my team, miters, right? Yes. Here we go. Just stay back. Mario.
Two graduation in 1 month. Very impressive. Thank you, sir.
Thank you. Dr. Jalan.
All right, buddy.
And Takatela family.
You should be holding this.
There.
Thank you.
You guys stay back. All right, Beth, we're going to take a picture together. All right? All right.
Big smiles. You guys did it. 1, 2, 3. All right.
Thank you. Thank you all. All right?
Thank you.
Thank you. Thank you, guys. Thank you.
Thank you so much, man. I appreciate it.
Thank you.
Yeah, we're not done yet. You guys are going to give me a...
Going to the bar.
You can start our watch.